So stainless steel or any alloy, it expands a little bit when temperature go up, right? When the day is cold, it shrink a little bit. So that increase or that expansion or that contraction of the stainless steel of the material itself cause something that we have to put in the equation. So they try to get every small detail accurate. So in the equation that we do, what do we do, Megan or Haley? Energy balance, right? Do we account for the thermal expansion of the material? No, we did not, right? Do we account for the elevation or the location, how far we from the equator? We did not, right? So we did not account for the fluid temperature change a little bit due to the drop in pressure and change in temperature. So those things account by this factor, okay? Marshall, can you help me with putting a larger version or part of the PDF file about this part on the Blackboard this week so that they can do homework next week? Okay. So detail for the calculation. So what do you do if you get stuck? Read this. Read this one, okay? When you get stuck, cannot do it, you read this thing, okay? Not many pages. So this part, let me skip and put it in the homework instead. So let's talk about orifice meter selection. How do we select the orifice? So factors need to be considered. Maximum peak hourly rate. What kind of peak hourly rate do you have? Do you have 10 million standard cubic foot per day? Sometime. Or you always have just 1 million standard cubic foot? So you need to know the flow rate, right? To select the middle run orifice plate, we need to know the flow rate. The maximum, the duration of the maximum or the peak or uniformity of the flow. Minimum flow rate, maximum flow rate. And metering gauge pressure required and available. Permissible pressure variation, how much the pressure drop that we expect or something. So if we look at the plate, you select smaller hole if you have low flow rate. Make sense to you? It doesn't make sense. So you select larger hole if you have more flow rate, higher flow rate, so that the pressure drop will not be too much. Okay, that's what it is. The working range of orifice plate and differential gauge is from maximum capacity to about 1/16 of maximum. So that's what we want to keep in mind, okay? So if you have very slow flow rate, that is like 1% of the range, it may not detect anything. The selection method, differential HW should not exceed the static pressure. Differential head. Okay, so this is something to keep in mind when you select that. How many do you want to memorize? You should memorize about a couple things on the slide. Doesn't mean that you have to memorize everything to pass the test. You just memorize something. The middle run ID should be at least 1/3 larger than the orifice opening. Do you want to memorize this one? Okay, go for it. If you don't want to memorize something else. Okay, both the differential and static pressure pen should probably operate within the middle 60% of the recording chart. Let's memorize some reason for that impact the accuracy. Most of the time, the middle run you select based on the flow rate. Okay, and when the can actually tell you based on your flow rate and your pressure, temperature, and flow rate, and what kind of gas you have, they can tell you. So what they won't tell you is what happened that can impact the accuracy of the overfit plate. So you have condition of the overfit plate. Condition of the overfit plate impact the accuracy. Okay, the possible deviation from specification that upstream edge of the overfit plate be square and sharp. So if you have the plate that look like this, over time it erodes a little bit. So instead of sharp edge, it's not sharp anymore. That impact the accuracy. Okay. Condition of the middle tube. The coefficient are obtained with the test with commercial iron pipe with corresponding roughness. Measurement would be high with 2 smooth pipe and low with 2 rough pipe. What does that tell you? So the pipe roughness can cause some pressure drop, right? So the roughness of the pipe, if it's very rough, it causes more pressure drop. So this kind of roughness of the pipe can impact your measurement. So I know many of you don't sleep, but you just close your eye while listening. I don't want that. I want you to open your eyes. Okay? I want you to open your eyes. Pulsation. That's number 3. Indefinite affect the measurement. Compressor valve, liquid surge, pressure regulator. So if you have pulse, go to the plate. That impact your accuracy. Okay, you don't want pulse. Wet gas measurement. So a problem that has never been completely solved. If your gas, overfit plate, by the way, is not for water. Okay, this overfit plate meter run is for gas, natural gas. If you have wet gas, a little bit of water, that causes you problem. Okay. Accumulation of liquid ahead of overfit plate disturb the normal flow pattern and coefficient of the overfit. You don't want any liquid in the system. If there is any liquid, that's cause error. Cause some error. Okay, number 1. Oh, what's this? Okay, number 1 condition. Number 1 reason that impact the accuracy of reading is pumper change the overfit plate and does not note on chart or report to anyone. Okay, when you change the overfit plate, you don't tell that, okay, the size changed already. Originally is bigger size, okay, maybe small size work as well. It's just have a hole in the plate, just put it in. Don't you think they think about it that way? It can be. Oh, what kind of plate do I put? I put the plate that has the hole in the middle, and then I put it in. It should work. So it's not the same. Every plate has a hole in the middle, right? But it's not the same diameter. So if they put it in and they don't tell you, that's cause a lot of error. And if they put it in the different side, sharp edge on the downstream, can they put sharp edge on the downstream on the senior fitting? They can still do that. There's no like notch over here that cannot put it other way around. So there's a chance that pumper put it in different side. Does it impact the accuracy? Significantly, I think. Is it?
And almost any inaccuracy in a meter works to the advantage of the buyer. Most of the time, your jobs, you'll be representing the upstream side. So if it's not metering right, you're losing money. If you're working for a midstream company, forget what I said.
Okay, a little bit on mass flow meter. Overfit meter may be used to measure gas on mass flow basis, but overfit meter doesn't really measure the mass, okay? It measures the pressure drop and convert that pressure drop to mass. The one that measures the mass directly is Coriolis flow meter. The density of the flowing gas is measured with densitometer. The densitometer is substitute for the static pressure element method to determine the specific gravity and supercompressibility correction necessary. So there's a formula for W mass flow rate with F sub B, F sub R Reynolds number factor, expansion factor, and this reading. Okay, those numbers come from Haley. Come from where? How do you get F sub B?
Chart.
What? Chart?
Sure.
Oh, okay. It's kind of table, right?
Yeah.
Yeah, okay. Yes, get it from that. Okay, done. Question for me. Do the homework, okay? Will it be in the exam? Okay, oh, wait. What will be in the exam? I can tell you for sure. These 5 reasons, you have to pick like 2 reasons. You don't memorize all, you memorize just 2. Next part is, you need to know that flange tap and pipe tap has different table for the same coefficient. Okay. Next step that you need to know is this parameter, they account for what? For example, can you give like 3 examples of this parameter? What do they account? They try to do what? Just 3 examples. One example you can say account for the location of the meter, whether how much is off from the equator or how much is off from the sea level. That's one factor, right? Number 2, thermal expansion of the meter itself when the temperature change. Okay. You can say number 3, Reynolds number factor. So we have 11. You may pick 3. Memorize 3. Otherwise, it's equivalent that you didn't come to the class. Okay. Memorize something. Where's the sign-up sheet? May I see, please? Who haven't signed the name? Okay. Let me call. Who want to go first? Someone that I never call. Okay, next to Shane, what's your name?
Jaden.
I didn't call you your name already. Okay, back. Jaden, what's your name, sir?
Luis.
Luis, can you give me 2 reasons that make inaccuracy on Orphic plate meter run, the measurement of meter run? 2 reasons, not 2 reasons. Luis, come on. Number 1 reason that make inaccuracy in the measurement. What is that? Or number 2 reason, or number 3, any reason that make inaccuracy in the Orphic plate measurement? I didn't hear that. Who want to help him? Next to Luis, what's your name, sir? Andrew. Can you give me some reason that make inaccuracy in the Orphic plate measurement so that we can move on to the next topic, please? What is? Can you give me some reason that cause inaccuracy in the Orphic plate measurement?
It can be eroded.
Yeah. You hear that? Was it Chris or no? What's your name again? Luis. Okay. Now you know that, right? Memorize it. It is in the exam. And you appreciate that I emphasize you, right? I tell you that it is in the exam. It will be in the exam. What else can be in the exam? It's not in the quiz. So sad, but it's in the exam. Let's do something else. I upload the material that we will go over on this tomorrow lab. Okay, you bring your safety class, and I found that it's quite maybe easier to explain it first in class and then go take a look. Okay, many of you have seen slug flow. Have you seen slug flow? Who have not seen slug flow? Luis, have you seen slug flow? Yes or no? You have seen slug flow? No, okay. Andrew, have you seen slug flow?
No.
No. Oh, okay. Slug flow you will see in the lab. It looks like this. It's a pocket of liquid, like a plug of liquid, move on top of the liquid film. Okay. So when that happens, you have some liquid film will pick up and release at the back. Slug flow. Okay. Oh, what's that? Oh. Let me open the new one. Slug flow. Who have seen slug flow already? Who take nodal analysis with Dr. Hansi? Okay. Jacob, have you seen slug flow? How does it look like? Can you describe it?
Just like flow flows
Good. I have slug flow from the lab. Okay. This one we call proto slug. It's not quite slug flow. Okay, you see something travel very quick. Most of the time the flow is separate, but sometimes something you see that kind of liquid occupy the whole pipe, but will be very short slug. So we don't call that slug flow. This is a graduate student that get a master already. So this one is still kind of proto slug flow. Okay, slug flow. There's no sound. Sound just look like that. Okay, so we have. Oh, this one is pretty fast. Close to annular flow transition. In the lab, I cannot show you annular flow, but downstairs in my flow there is an annular flow, but we don't do anything with downstairs yet. Okay. All right, you have flow, and there's a film. Slug flow will be more like slower than this. Okay. What happens is the liquid pocket can pick up some mass up and shed back at the end. Okay. And tomorrow we will see that. We cannot cover everything. We can cover something for this 1.5 minutes before we do the quiz. Let's do the quiz with less time. I think you already know the answer. Instead of 10 minutes, let's do 5 minutes. Carter, do you still remember those equations that we taught? Yes? Are you sure? 2F with gravity? Still remember that? Yeah, let's do just 5 minutes test. Okay, let's take a look at this. Tomorrow when you see in the lab, the part that has slug body, we call it LS. Okay? The part that you will see film, we call it LF, film length, slug length. What happened is, I want to show you that this front move a lot faster than fluid particle inside. Let's say we have some particle inside. So this particle stay over here. We have slug flow, slug body, this part will pick up the mass. Okay, if you pick up the mass, it go inside, it rotate inside the slug. And then this slug go that way. It shed the particle at the back, release it at the back. And then next slug will pick it up. If you take a look at this, you see this front, slug front, travel from that point to that point and then to that point, and then to that point. You see that, right? Carter? What's the name of the person behind you? Yeah, what's your name?
Adrian?
Andrea. You see this one?
Yeah.
And the particle travel just from here to here. Which distance is more? Which distance is less?
One further right.
So the distance that slug front travel is more than the distance that the particle travel, right? Particle travel just a little bit, but the front travel a lot. Okay, you get that? So tomorrow I'll show you how to do some calculation. What you need to know is this part travel faster in the flow. The front part, okay, that front travel the fastest part in the flow. So when this front pick up the mass, it releases at the back, and then this mass travel inside the film. Okay. For the multi-phase flow, we won't cover it yet, but we will go to the lab to see see the phenomena in the lab. What you can do for me is go to Blackboard, review the solution. Okay. This is the question with the solution. You see, solution is in green. It is already with the solution. So what I will ask tomorrow is about which parameter means what. Can you do that for me? Yes, just go back home and read it before attending the lab tomorrow. And we do the calculation based on the relative velocity idea. Probably you don't need to want to know that anymore. You want to do this, right? Okay. Wherever you can, it is closed book, closed note, no laptop. Okay. If you cheat, you get F for the class. Okay. Put wherever possible, please separate from the student sitting next to you. We will have about 5 minutes quiz instead of 10 because we already reviewed the solution. Okay, so wherever possible, you separate. You put it down. Don't take a look at it yet. The quiz is easy because you already know the solution. So you don't write it. You can write your name on the back. Okay, but you don't look at the question yet. Don't take a look at the question yet. We will start at the same time and stop at the same time, and it will be about 5 minutes.